All right, so this is part 2 of our radicals intro. If you haven't watched part 1, please go back and do that, and it talks a little bit about parts of radicals. So last time we talked a little bit about number of roots, and it says here, give all possible roots to the radicals. So you know that the square root of 49 is 7, because 7 squared is 49. But you also probably know that negative 7 squared is also 49. So this really has 2 answers, even though when we write it out, usually we just write 7. This is really both positive and negative 7, so we can write it kind of together here. And part of that has to do with this index is really a 2 here. If it's not written in square root, that's really a 2 there. So that's even, and that's a big reason why then we have 2 roots. If your index is odd, like this one, here, then you have 1 root. And this is also the only time you can have a negative underneath the radical is if the index is odd. So a couple of different things about how we can find what the cube root of 729 is. You can use the chart that I gave you. You can also type into your calculator. So I'm actually going to do that, show you how to do that. Now, first of all, the square root is right here. So you have to hit second and then number and like 25 and type it in. But let's say you want the cube root or the 4th root. You can press this math button. You'll notice the 4th one down there is cube root. 5th one down, you can type in whatever you want. So let's say you want the, the 4th root of 81. Notice you get 3, okay? Or you can use this chart that I have in Schoology right here. You'll notice 729, cube root, perfect cube, is right here. And so my answer would be 9. Okay, that's how you can use that chart. So this is 9, but because it's negative, the only way I could get a negative is if this is actually negative 9. Negative 9 times negative 9 times negative 9 is negative 729. So this would be negative 9. And notice we only have 1 answer because my index is odd. If your index is even, you'll have 2 answers. So here it's even again. 2,401 is the 4th root of that is 7. So this is going to be plus or minus 7. Okay, that's it. And this chart is handy. I would suggest you print this out or have it in Notability and just reference it all the time during these units because you're going to want to come back to this. It goes all the way up to 15, but I put 10 in here. All right, so how do we simplify radicals? First of all, when we are simplifying, you only need to write the principal root, which is just really the positive root. You don't need to write plus or minus when you're doing this. If they say write all the roots, then you should do plus or minus. Okay, so let's try this. The square root of 117 is not a perfect square. You can look at your chart. You'll notice that it is not a perfect square. So you want to say what are some numbers, perfect squares, like 4, 9, 16, 25, 36, 49, that go into 117. So the easiest way to do this is to say, all right, what are some perfect squares? Go 117 divided by 49. Now, if I go a little bit higher than that, 64, that's going to be too big if I go, I won't get, that'll be less than 2. So I really can work my way down from here. Okay, 117 divided by 25, no. 117 divided by 16, nope. 117 divided by 9, yup, 13. Okay, so it's 13 times 9. So here's how you'll do that. You're going to break this apart. You're going to write the square root of 9. You'll write the perfect square first, always first. And then you're going to go times square root of 13. Notice I put them both, those are both square roots. Square root of 9 times square root of 13 is a square root of 117. So this is how you can break them apart. Still means the same thing. Now to simplify, you just say, what is the square root of 9? Well, we know that that's 3. And then afterwards, you're going to put this radical root 13. When they're right next to each other, that means multiplication, just like when you do 3x. One thing is you will always write this number in front of the radical though, okay, not after. So that's some notation. So here's my answer. All right, and now you've just simplified that radical. Okay, so the trick really is about finding what is the biggest, it has to be the biggest perfect square that goes into the radical. So first I have 4 times, this is 4 root 320, so this is really 4 times, and now I'm going to break this apart. So put the perfect square times the other part. Okay, so what is the biggest perfect square that goes into 320? So we'll go 320 divided by, might run across 16, 320, but also 64 works. Now you would play around and get this. So then you want to use the biggest one. So you always want to try, and you can play around with this. But one thing I noticed is that 20, if you think about that number, if you break it apart, 4 times 5. 4 is a perfect square. So this is an indication, if you still have a perfect square as one of those factors, you know that it's probably not simplified. So 64 and 5 is what I want to use. All right, so this is perfect square first, and then the other one second. So now square root of 64 is 8. And now I'm just going to go 4 times 8, that's 32, times square root of 5. And there we have it. Okay. 2 times the cube root of 48. Now, if we look at our cube roots, let's go back to our cube root. The biggest one, it's 48, so the biggest one that's going to go in here is only 8. So that will give us 2 when we take the cube root. So that kind of makes our job a little bit easier here. I suppose I should switch colors. Let's go 2 times, okay, cube root of 8 times cube root of, that would give us 6 left over. So now 2 times the cube root of 8. Make sure you're always doing cube roots. It's easy to accidentally write 4 here or something. Just take your time. Okay, so now I have that. So now 2 times 2 is 4. Oh, I guess I don't need that dot. So this is 4 times the cube root of 6. And that's my answer. All right, hopefully that makes some sense. Let's try another one. So here I have 3 times cube root of 108. I want to break apart, and what's going to be the number that's going to go in there? So I said the biggest number, cube roots now, and if you do a little playing around with this, you'll get 27 is the biggest one that goes into 108. So that's the biggest perfect cube. So now this is 3 again. It's got to copy that. The cube root of 27 is 3. And then, okay, so this is 9. Okay, so now I have 9 times the cube root of 4. And that's my answer to that. And now you've just simplified some radicals. Okay, I want to do another one here. So if you take a look at, let's take a look at this first one. Notice it's got a negative. So whenever you have a negative, you want to pull that into the perfect square, or in this case cube, part of your problem. So when I break this apart, you can just start by writing that. All right, so let's look at perfect cubes. So that was 250, negative 250. Well, oops, 125 goes in there. That's double that. So that's what we want to use. All right. So when I say 125 here, I'm going to put that right here. However, now I said I want to put that negative with that. You always want to put that in the perfect cube part, okay? And then what do I have left over? This would be cube root of 2. So now this right here is negative 5. And this is the cube root of 2. So now I have my answer there, and that's how that works. All right, there's three other problems here. I'm not going to do those right now, but I did do these. If you want to look, I went through and did these step by step, so you can come through and look at this video and see how I got those for some more examples if you'd like. Okay, hopefully that helps. Your assignment is Intro to Radicals worksheet. Don't forget to write that into your planner as well. Good luck. Hopefully this makes sense. See ya.